Hi everybody, this is Mr. Fowley, and while you're getting a periodic table, I will make my pen work. And welcome to Podcast 3.3. We're going to do electron configurations, noble gas configurations, and orbital diagrams. Welcome to that little bonus. So let's go ahead and get started with that. Maybe. Atoms come with electrons, but it's helpful to think of atoms as adding of electrons one at a time. This means we need a filling order. Aufbau is German for building up, so that means the lowest energy ones go in first. Why low energy? Remember, high energy is unstable. So think of a building. So if I have some building with a tower on it, Sears Tower or whatever it is now, high energy earthquake, what happens? The building falls down. Or you have a baby. Oh, cute little baby, goo goo gaga gaga goo gaga. If you shake the baby dies. Don't ever shake a baby even once. It causes brain damage and death, which is sad. And it is. Periodic table shows this order. This part right here, and you need to be able to label this, is the S block. And this part is the S block too. This right here is the P block. D block and F block. Okay? This will help us show the order. We start with the top and go across. Okay? We do need to know that S is a sphere-shaped. Spherical shaped. P is called dumbbell, and D is just called complex because it is. I'll show you these pictures in class. And F is complex because it is. I'll show those pictures in class. We don't have good words to describe it. How many columns are in the S block? Let me go back. Oh, one column, two columns. Oh, I'm going to select two. How many electrons? Two. So 1s2 would be the first row, S1, first row, S2. Second row would be S1, S2. Third row would actually be 3S1, 3S2. Fourth row would be 4S1, 4S2. And I should have put my 2's here and my 1's here. So that's the way that we describe it. 3S2 is different how? It's on the third level and has more core electrons. How many electrons in the PDF block? Count the columns. Oh no, my pen's not going to work. Count the columns. So I've figured out this trick. P equals 6 electrons. Sorry about that. D equals 10 electrons. F equals 14 electrons because that's the number of columns. I've defeated my, and that actually should go with this guy right here. P6 is the max, D10 is the max, F14 is the max. Okay, so I put that on the other side. Okay, it can't hold any more than that. It's like how many donuts can you fit in a box of Krispy Kremes? 12. You can't fit 13. It doesn't work. Orbital diagrams show Hund's rule. Hund's rule says everybody gets 1 before anybody gets 2 of the same level. And let me show you how that can kind of work. So I talk about these orbital things. And the p orbitals, these are each p orbitals. If I were to add electrons, and remember how I said the boxes hold 2, the p holds 6 at most. I have 1 up here. If I were to put a second one in, I'm not going to put it right here. I'm going to put it in the other box. So notice how all of these p orbitals get 1 before anyone gets 2. Okay, so everybody needs to have 1 before the second one goes in. I also kind of use this, and this only works for guys, but it's kind of like the urinal rule. If a guy goes right here, the next guy in does not go to the spot right here. They leave a little buffer zone. Okay, so you always leave a little bit of space because electrons are negative and they repel each other, so they're going to spread out a little more. The Pauli exclusion principle says only 2 electrons can fit in an orbital. Do you notice how this holds 2 electrons? I can't fit a third one in there. So the Pauli exclusion principle says, you know what? Orbitals only hold 2, which is why P can hold at most 6. Okay, I just get it. P orbitals, urinal things. Now, this is best done by example. Neon, I get out my periodic table, because you already have yours. Neon has 10 electrons. And to show you how these things work in general, I have one S, which holds 2. Remember, a box holds 2. The box is an orbital. Orbital diagram, orbital is a box of 2 electrons. 1s, 2s, 2p. Remember, 2p holds 6 electrons. So 6 electrons would be this many boxes. And then 3s. And this part will be given to you. Okay. So I have neon. I have 10 electrons. The first one goes in the lowest one. Who says they go in the lowest? Off-bow. I know that's not a person. It says go in the lowest. Who says I can't put a third one in there? Who says I can't put 3 in there? That's Pauly. At most 2 go in there. So there's 2 electrons. 3 electrons, 4 electrons, 5, 6, 7. Notice up, up, up. 8, 9, 10. And I stop. I don't add any more. These are empty. Aww. Now why did I stop there? Neon has 10 electrons because neon has a little 10 up here and a 20.18. We're talking about the neon atom, so that's where it goes from. Okay. If I were to do iron, looking at the periodic table, iron has 26 electrons. Ooh, that's a lot more. Again, it'll start the same. 1s, box. 2s, box. 2p, because it holds 6, box, box, box. 3s, box. 3p, box, box, box. 4s, box. 3d comes next. Isn't that weird that 3d comes next? Now d's hold 10. 1, 2, 3, 4, 5. If it holds 10 electrons, then it would hold have 5 boxes. And then next would become 4p. Okay. So if I have 26 electrons, I'm going to start filling them up. 1, 2. Start at the bottom. Thank you, off ball. I only put 2 in there. Thank you, Pauly. 3, 4, 5. Up, up, up. That's Hund's rule. Everybody gets 1 before anybody gets 2. Down, down, down. 2, 4, plus 6 is 10. There's 10 electrons so far. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I need 26. I need 6 electrons in here. I do not go up, down. I go up, 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 and then one of them goes down. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23, 24, 25, 26. This is iron. And notice how 4p would just have empty orbitals. And that's okay. Electron configuration is taking up less space. Now if I'm looking at this, if I were to write the electron configuration for neon, it would be, see this right here? 1s2. See this right here? 2s2. See this right here? 2p6. Why 6? 2, 4, 6. Sweet. Starting from the bottom here, 1s2. Check. 2s2. Check. 2p. 1, 2, 3, 4, 5, 6. Check. 3s2. 3p. 2, 4, 6. 4s2 and 3d6. Okay. And then this would have 1, 2, 3, 4 single electrons. Electron configurations take up less space, so we don't need to do the orbital diagram for it. So what we're going to do is look at the periodic table as we do this. Okay. 1, 2, 3, 4, 5, 6. Okay, carbon. Carbon on the periodic table has 6 electrons. Okay, so I'm going to start at the top. First row, S block, 2 electrons. Second row, bam, S block, bam, 2 electrons, bam. Still on the second row, bam, P block, bam, 2 electrons. You really going to do this to me, you stinking thing? 2s. Let's see if it'll go back to it now. I just wrote that just for grins, so I could maybe write it here. 2p2 because it's p1, p2. Okay. Rubidium. Rubidium has 37. Goodness gracious. Going across. 1s2. Going across to the p block. 2s2. Going across. I'm not stopping yet, so now I'm going to go 2p6. Now you're going to need to look at your periodic table because it's harder to see now. I'm now in the third row. 3s2. That's sodium and magnesium. Then I'm going to have 3p6. That is aluminum through argon, right? That's aluminum through argon. Then after that, I'm on the fourth row. 4s2. That's K and Ca. Then I've got to do the next part. Now remember, that middle part is the 3d. That 3D, even though it's on the 4th row, D is 1 level higher, right? So even though it went from 4S, it goes to 3D. And I go all the way through there to zinc, 3D10. That includes up to including zinc. Then I'm back to the 4th row, 4P6, and then I have 5S. Now notice how rubidium's right here, so it's in the S1 column. Okay, I thought I got rid of SM, and I meant to. But no, that's okay, because the next thing I talk about is right here. SM, I don't even know where SM is. Oh, SM is number 62. SM is a nightmare. There's a lot of repetition, so a way was developed to show the outer electrons only. Outer electrons, hey, those are valence. Valence electrons, hey, that's the outer electrons. It's typically S and P, and the other blocks are core. So valence is typically outer, S and P, and the other blocks are core. Core notation is synonymous with noble gas notation. So if I were to hop back here and give you the core notation of rubidium, see how rubidium's outer level is the 5th level? It would simply be the preceding noble gas. So the noble gas to the far right-hand side. So if I look at krypton in brackets, that means krypton takes care of all of these. Okay? And then all I write afterwards is 5s1. And that tells me, oh, it's in the 5th level, S block, 1 electron. And by being in that S1 block, it says, oh, it's very reactive and such. If I do the same thing for carbon, preceding noble gas for carbon would be helium. Right, here's carbon. Preceding noble gas is here. And then the biggest energy level is 2. 2s2, 2p2. Okay? And we're skipping the F blocks if you haven't noticed that. For the following elements, do calcium. So going across, 1s2, 2s2, 2p6, and that takes me up to neon. The next row, 3s2, 3p6, and that takes me up to argon. Then I have 4s2, and I stop at s2 for calcium. Calcium has 20 protons, 2, 4, 10, 12, 18, 20. That stops at calcium. If I undo the core notation of calcium, the preceding noble gas is number 18, which is argon. Right? So I put argon in brackets, and all I have left is 4s2. This is noble. Okay. dy66, which I thought I got rid of dy. There was a reason why I wasn't going to do it. I don't want to do 66. I'm going to change it. I'm going to do molybdenum. I'll do silver. No, I'll do molybdenum. Yeah. Molybdenum only. So mo, number 42. Look at me changing on the fly. So the preceding noble gas of molybdenum is krypton. See, molybdenum is number 42. Number 36 is the preceding noble gas. That's krypton. So put krypton in brackets. Number 37 and 38 are 1, 2, 3, 4, 5. 5s2. Then I get into the D block. Now remember, it's not going to be 5D, it's 4D because it's bumped. 1, 2, 3, 4. 4D4. And that is good enough. Of course, I picked one. That's no bad choice, but that'll work. So 4D4. Review. S, P, D, F. Electrons move up. Woohoo! Periodic table helps. D block goes up one. And we are finished with this. Toodles.